Hello and welcome. In this video, we're going to review parallel and perpendicular lines, and we're going to extend that idea to geometry. Our goal in this lesson is that we can use slope to determine if lines are parallel, perpendicular, or neither, that we can write and graph equations of lines passing through a point that may not be on that line but is parallel or perpendicular to a given line. And lastly, that we can find the distance from a point to a line and write the equation of the line that represents the perpendicular bisector. I know that sounds like a lot, but much of this is algebra review, and then we'll really dig into the new stuff. Let's go ahead and jump in. All right, so what we have learned and discussed previously is that if two lines are parallel, that means that they have the same slope. We also know that if two lines are perpendicular, their slopes are opposite in sign, so one of them is positive and the other is negative, and they are reciprocals of each other. And we have talked about how that actually means that if you multiply their two slopes, that you would get -1. If we tie this to a coordinate plane, we can also say that in a coordinate plane, the x-axis and the y-axis are perpendicular. If you think about what that looks like visually, we have the y-axis and the x-axis, and they do intersect at a right angle. The y-axis has a slope that is undefined, and the x-axis has a slope that is 0. Horizontal lines that are along the horizon would by then be parallel to the x-axis because all horizontal lines also have a slope of 0. And vertical lines will all be parallel to the y-axis because they also all have a slope that is undefined. We also reviewed in class point slope form, which is my personal favorite. Point slope form allows us to just write the equation of a line with a slope and a point, and we can identify the slope as the value in front of our x quantities. And slope intercept form, where we can pull the slope from this value. So now that we have reviewed some of what we already know about parallel and perpendicular lines, let's formalize some theorems and postulates. All right, here we go. We have two theorems or postulates in this section, and they are pretty intuitive. They make sense if you think about them. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So now we have a postulate that we can use to talk about the slopes of parallel lines. Parallel lines have the same slope. Let's actually add that here. What we're really saying is that parallel lines have the same slope, and then there's this added piece, any two vertical lines are parallel because they have the same slope as well, and that slope is undefined. So the key thing in this first postulate is that parallel lines have the same slope. And this isn't new information. We've been talking about parallel lines having the same slope way back since Algebra 1. Our second postulate or theorem is going to talk about slopes of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So this still means that their slopes are opposite and reciprocals, but the way to mathematically verify that two lines are perpendicular is to multiply their slopes and get -1. The other little added piece here is that horizontal lines and vertical lines are perpendicular. So now that we've formalized these rules in theorems and postulates, let's go ahead and look at some examples. All right, for both of these examples, we are given four lines. A, B, C are all here on example 1, and then D is this other line, this purple line off to the side here. And then similarly on number 2, A, B, and C, and then D is this line over here. We are going to determine which of the lines are parallel and which are perpendicular. And in order to do that, what's the key thing that we need? We need to find their slope. Now remember, if we're given a graph to find the slope, all we really need to do is to find the rise over the run. So let's look at line A first. The slope from this left point to the right point is going to be how much I'm rising, which is 1, over how much I'm running, which is 3. So actually, let's just remind ourselves that our slope is our rise over our run. So line A is going to have a slope of 1/3. Line B, if we look at the 2 points we're given on line B has a rise of 1 and a run of 2. so has a slope that is 1/2. And then line C has a rise of 1 and a run of 2, so also has a slope of 1/2. And then our very last line, line D, if we go from left to right on line D, we have a rise of -2 because it's going down 2 and a run of 1. So line D has a slope of -2 over 1 or just -2. Now that we have identified each of these slopes, we can make comparisons. Line A isn't parallel or perpendicular to any of the lines here because its slope isn't the same, and it's not the opposite reciprocal slope for any of these lines as well. But lines B and C have the same slope, so we can say that line B is parallel to line C since they have the same slope, which is 1/2. We can also say that line B is perpendicular to line D, and therefore line C is also perpendicular to line D. And we can show that that's true using the postulate we just learned, where we multiply or find the product of their slopes. Line C has a slope of 1/2. Line D has a slope of -2, and that does in fact multiply to be -1. And the same thing for B and D. I'm going to have you go ahead and pause the video. First, find the slope, the rise over the run for each of the lines on number 2. Then compare the slope, writing statements for parallel and perpendicular. Then unpause the video and see how you did. So here are the slopes for those 4 lines, and now we can write statements comparing them. We can say that line A is parallel to line B because they have the same slope, which is 2. And we can say that line C is perpendicular to line D, again, because the product of those 2 slopes is equal to -1. Now let's talk about equations of lines. For these 2 examples, we are going to write the equation of a line using the given information. And this is going to focus again on parallel and perpendicular. So if we look at number 3, it says write the equation of a line that's passing through this point, -1, 1, that is parallel to this line. So as I pointed out in class and we have talked about, the best way to write the equation of a line is using point-slope form. When you do that, you just need to plug in your slope and the x and y coordinates of any given point. So before I even worry about the parallel part of this, I'm going to go ahead and just set up the equation of my line. So I'm going to plug in the x value of this point, which is -1. I'm going to plug in the y value of this point, which is 1. And now all I need to finish this equation of a line is the slope, which I'm going to plop right here in my M spot. This line is currently written in slope-intercept form, which means I can identify the slope as that coefficient in front of x. The slope is 2. Parallel lines are going to have the same slope, so the parallel slope will also be 2, and I can plop that here. And then the only thing I'm going to do is I'm going to just change this minus a negative to become +1. There is no reason for you to distribute and combine like terms and move this 1 over and isolate y if all we're being asked to do is write the equation of a line. We should stop right here. Unless you're being told to put something in slope-intercept form, it doesn't benefit you to do so. Slope-intercept form is great when we are graphing, when we're just writing the equation of a line. Just stop here. If we look at number 4, before we even jump into parallel perpendicular, we're going to identify the point, and I actually want you to just set up what you know without the slope like I did over here for number 4. Okay, hopefully you had time to do that. So I'm going to say y minus something is going to equal the slope, which I'm leaving for now, times x minus something. The x value of this point is 2, and the y value of this point is 3. So now I need to figure out what's going on with my slope. So I'm going to look at this equation. This equation is not currently in slope-intercept form or point-slope form, but I could put it into slope-intercept form if I just subtract 2x on both sides. That would give me y equals -2x plus 2. Now I can identify the slope in my original line is -2. This problem is telling me to find the slope that is perpendicular to -2. So I need to figure out what the opposite reciprocal is. Well, since this is currently negative, my new slope is going to be positive. And I'm looking at 2. If I reciprocate 2, I'm going to get 1/2. So my new slope is going to be 1/2. And here I have the equation of the line that is perpendicular to this line passing through the point 2, 3. Let's look at a couple more examples before we actually get to the new geometric piece in this lesson. Okay, I'm going to encourage you actually to try and do both numbers 5 and 6 on your own, and then unpause the video and see how you did and walk through it with me. Okay, hopefully you had time to do that. For both 5a and 5b, I am using the 0.15 and I'm writing the equation of a line. So I'm going to go ahead and set up what's always going to be the same in the equation of my line. So y minus, leaving space for my slope, x minus. For both of these problems, I'm using the 0.15. So the x coordinate is going to be 1, the y coordinate is going to be 5. And all I need to do now is to find the slope. If we are parallel to the line, y equals 3x minus 5, which is in slope-intercept form, then my parallel slope is going to be 3. My perpendicular slope is going to be negative since 3 is positive, and I'm going to reciprocate 3 to get 1/3. And there I have the equation of both the parallel line and the perpendicular line that pass through the 0.15. Number 6 is asking us how we know that the line x equals 4 and y equals 2 are perpendicular. So the first thing I want to do is I want to make sure we know what it looks like to have the line x equals 4 and y equals 2. Notice x equals 4, this is only an x line. There's no y. That means that is a vertical line that passes through where x is equal to 4. Y equals 2 is going to be a horizontal line that passes through y equals 2. So if we have a horizontal and a vertical line, we know that they are perpendicular because of the slopes of perpendicular lines postulate that we learned in this lesson. So we're just going to say, since we have a horizontal and vertical line, they are perpendicular by the slopes of perpendicular lines postulate. And there we have it. Okay, the last part of this lesson is really the new piece, and it is a more complicated piece. So take a big breath because we can do this, but it's going to take a little bit of time for us to work through. So what we're going to do now is we're going to find the distance from a point to a line. The distance from a point to a line. In order to do this, we're going to have to keep in mind that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So I'm going to just create a little sketch here so you can see what I'm talking about. So here's a visual of what we're talking about. We have the line y equals negative x plus 3, and we have the point 1, 0. We're trying to find the length or the distance from this point to this line. So what we first need to do is we need to find the equation of the line that's perpendicular to this black line that passes through this point so that we can figure out where those two lines would intersect, and then we're going to find the length that we're looking for. So we're going to do this step by step. The very first thing we need to do is we need to make sure we know what the slope of the perpendicular line is. So step 1, find the slope of the perpendicular line. If this is our original line, our original slope is -1, which means our perpendicular slope is going to be +1 because it needs to be the opposite and the reciprocal. We can use that in step 2 to write the equation of this perpendicular line that's passing through the point we care about. So y minus the y value is 0 is going to equal the slope, which we just found the perpendicular slope we want is 1, times x minus the x value. And I'm going to go ahead and just rewrite this. This is going to, if simplified, to be y equals x minus 1. The third thing we're going to do is now we have two lines. We have the equation of two lines. This line, two perpendicular lines, right? What we need to do is we need to figure out where these two lines intersect. So we're going to go back to an Algebra 1 topic where we're going to figure out where they intersect by solving this system of equations. So I'm going to write solve. I'm going to write the equation of both lines on top of each other. You can solve this using substitution or elimination. If you want to use substitution, what you could do is you could plug in x minus 1 right here, and then you could solve for x and plug that x value back in to either of these highlighted equations to find y. I'm going to solve using elimination. So what I'm actually going to do is I'm going to subtract these two. I'm going to add these two equations together. If I add y and y, I get 2y. If I add x and negative x, I get 0. If I add 3 and negative 1, I get 2. And if I solve for y, I'm going to divide both sides by 2, which is going to give me that y is equal to 1. If y is equal to 1, then I can say 1 equals x minus 1 to solve for x. So x is going to be 2. So the point that they intersect at, I'm going to write intersection. The point that they intersect at is the point 2, 1. Now that I know that they intersect at the point 2, 1, I just need to find the length of this segment here. In order to do that, we're going to use the distance formula. We're going to find the distance between this point that we just found and the original point that we were talking about, which was 1, 0. So we're going to say distance equals the square root of the x values, so 2 minus 1 squared, plus the y values, 1 minus 0 squared. And then we're just going to simplify. So this is going to equal the square root of 1 plus 1. So the distance is going to equal the square root of 2 units. And there we have the length from the point 1, 0 to the line y equals negative x plus 3. We're going to look at one more example, and then we're going to go ahead and wrap up this video. Okay. We're going to go through those same steps that we did in the last problem. So the first and second steps say, first, find the slope of the perpendicular line, the line that's perpendicular to the given line, and write the equation of that perpendicular line that passes through this point. So I want you to just do those two things. Identify your new slope, and then write the equation of your perpendicular line. Okay, hopefully you had time to do that. Our line is going to be y minus 4 is equal to our current slope is 1, which means our perpendicular slope is going to be negative 1. So y minus 4 is going to equal negative 1 times x minus 6. The third thing, since we did the first and second, find the slope, write the equation of the perpendicular line. Now we're going to solve the system of equations. And I'm going to do this one using substitution since we used elimination on the last one. So now we're going to solve. So what I'm going to do is if y is equal to x minus 4, I can substitute that in for y here. So I'm going to get x plus 4 where there was a y, and then everything else that was here equals negative 4, and I'm going to go ahead, is going to stay the same. I'm going to go ahead and distribute on the right-hand side, though, negative x plus 6. So now, if I add 4 and negative 4, I'm going to get x equals negative x plus 6. I'm going to add x on both sides, which is going to give me 2x equals 6, which means that x is equal to 3. If x is equal to 3 and y is equal to x plus 4, that means y is going to equal 3 plus 4, so y is going to be 7. So we just did all of this work to find the coordinate of where we are going to intersect. And I'm just going to, again, write the word intersect. So we needed this coordinate because now we're going to use the distance formula to find the distance between these 2 points that we cared about. So we're going to find the distance between the point 64 and the point 37 using the distance formula. So I'm going to encourage you to pause the video, set up the distance formula, and then unpause the video and see how you did. Okay, if we set this up, we're going to get the square root of 6 minus 3 squared plus 4 minus 7 squared. This is going to be the square root of 9, since 6 minus 3 is 3 squared is 9. 4 minus 7 is negative 3. Negative 3 squared is also 9. So this is going to give me the square root of 18. We want to simplify this. 18 is the same thing as 9 times 2, and I'm picking that because I know that the square root of 9 is 3. So this can simplify to be 3 root 2. All right, let's go ahead and wrap up this video. All right, in 5.3, we tied a bunch of things together and we extended it to a new concept. We talked about the slopes of parallel and perpendicular lines and writing those equations. And we did that so that we could find the length of the segment bisector, or of the perpendicular bisector of a segment. Go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.